rules. And it's actually funny. So the way that this is presented, we have expanded exponents that we kind of trim down and condense, right? And you can go either way with exponents. We just don't do it as often, where we take b to the x plus y and actually separate it. You don't separate as often. Usually for exponents, it's about condensing. And the same is true for logs, but for whatever reason, they present it already condensed, and we're going to expand. So there will be times you'll be asked to expand a single log into 2 logs, and then vice versa. You'll be asked to condense 2 logs into a single log. So just like the multiplication of common bases turns into the addition of exponents, multiplication here for logs turns into addition log base b of x plus log base b of y. And if you had to guess, what do you think division for a log turns into? Subtraction, log base b of x minus log base b of y. This next one is the most unique and probably the most useful. You'll actually probably know it the best. Is when you take the log of something that has an exponent, that exponent gets written out in front. So it's y times log base b of x. And we will use that one most often, you'll soon find out. Okay? So, those are the laws. Now we're going to use them. Which of the following is equal to? So this is currently a single log of 2 things that are being, 9 and x are technically being multiplied. So to separate this, they would need to be added. So that's going to be log base 3 of 9 plus log base 3 of x. Now the beauty of this is that log base 3 of 9 is what? What's the value of that? 2. 3 to what power gives us 9? 2 plus log base 3 of x, so what's our answer? In just those few short minutes, Isaiah, you literally missed the whole lesson. Now we're just going to practice. Okay? In the next one, single log of division turns into, how do you expand it into subtraction? So log of x squared minus log of 1,000. Now this one had no base, so what is it? 10. So what's the value of this? 10 to what power is 1,000? 3. Good. And this is the log of something that has an exponent. What do I do with that exponent? This was property number 3. Bring it out in front. So that becomes 2 log x. So what's your answer? 1. Nice job. Exercise 3 would be tricky, but once I show it to you, you'll be like, oh, that makes a lot of sense. So they give you the log of 3 and they give you the log of 2. But they ask you, what's the log of 12? Now, it's all in terms of a's and b's, so a calculator is not helpful. So a is equivalent to the log of 3 and b is equivalent to the log of 2. They're asking us for the log of 12. So what we're going to do is, since we only know log 3 and log 2, we're going to break down 12 into just 3's and 2's. How can I rewrite 12 so that it's written with just 3's and 2's? Andrew. Well, let's go 3 times 4 first, right? So we just rewrite 12 as 3 times 4. Anybody had a different idea of how to rewrite 12? I'll do it 2 ways. Nathan. 3 times 2 times 2, fine. So now, Andrew's way, we're going to break up multiplication into addition. Log of 3 plus log of 4. So Andrew, why did you do 4? Because I wanted it all in terms of 3's and 2's. We can still run with what he did. How, Isaiah? 4 is the same thing as 2 squared. So for the log 3, that equals a plus, now that exponent can come out in front, so it's 2 times the log of 2, which is, what's the log of 2? They told us log 2 equaled b. So which answer is a plus 2b? 4. Now, if you're Nathan and you did 3 times 2 times 2, you're just going to do log 3 plus log 2 plus log 2, which is going to be a plus b plus b. And isn't b plus b 2b anyway? Yeah, so you get the same answer? Okay, good. All right. Again, they keep these in terms of x's and y's, so if you're Isaiah and you found out how to use logs on the calculator, they're going to write them so you can't a lot of the time. They're going to keep it all in terms of x's and y's. So what's the first way I would split this up? What do you think, McKenna? Base 2, log base 2 of, yep, keep going. Of y to the 5th. Excellent. But then obviously we have a follow-up property here. And it starts with this one. What can I do with the first term here? How can I rewrite that? Nate? Yes, because square root of x is technically x to the 1/2 power. So you can bring that 1/2 out in front. 1/2 log base 2 of x minus, bring that 5 out in front, 5 log base 2 of y. So there's 2 properties, almost 3 properties you have to know to complete that one. The separate to subtraction, the fact that a radical has a fractional exponent, and then bringing your exponents out in front. Really 3 things to know there to get that. Okay, flip to the back. 5 is almost the same. Trying to think if anything crazy comes up there. 6, okay, 6 composition of functions. They give us f of x, they give us g of x. They want f of g of x. So with compositions, you start on the inside, right? If we had a number there, we would figure out g of 7 or g of 8, but we don't. We just have g of x. So this entire g of x function, this entire 100x cubed, has to be put into the f of x function, which will create log of 100x cubed. So how am I first going to split this up? Mason? Not yet. Okay, because that 3 is only on the x. If I put it out in front, then it's going to be inadvertently on the 100 as well. So before that, Andrew. Okay, I could do that. What were you going to say, Nate? Okay, so we all need to kind of change the way we're seeing 100x cubed. We need to see this as 100 times x cubed and deal with that multiplication first. Try again, Mason. Let me go back to our properties. We're going to apply this one first. You got to kind of work on the, like, the outermost thing that's happening here is we got 100 times something else. So we're going to first split it up into a log of 100 plus log of x cubed. Now I can start doing some of that other stuff. But if I brought that 3 out in front right away, do you see how that would have inadvertently been on the 100, Mason? Okay? So now log of 100 is just 2, and this is 3 log x. Okay, yeah. Okay. Any questions on that? Look at 7. Now 7 has the radical over the entire thing. So this is like 32x to the 7th, all raised to the 1/2. Because the entire thing is raised to the 1/2, now I can take that 1/2 out in front before I can get started. So I'll have 1/2 log base 2 of 32x to the 7th. I can't bring out in front the 7 yet. I first need to take this and split it up into log base 2 of 32 plus log base 2 of x to the 7th. Now because that's split up into a binomial, I can't just put my 1/2 out in front. I have to insert what? Nope. Because right now if I just write it like this, my 1/2 is only being multiplied by this. The 1/2 needs to be multiplied by this whole thing, so you have to insert parentheses. Now, what's log base 2 of 32? 5. And then this is 7 log base 2. And then it's 1/2 out in front, but look at your answers. How are they writing it? They don't have the 1/2 out in front, they have the whole thing divided by